Hello friends, today in this part of program we will discuss about the basics of microcontroller 8051. This 8051 was the first 8-bit microcontroller designed by the Intel. Let us have the basic introduction to 8051 and its family members. The 8051 microcontroller is the most commonly used 8-bit microcontroller. Now let us see what are the basic criteria for choosing a microcontroller. First is meeting the computing needs of the task efficiently and cost effectively. Speed, the amount of ROM and RAM available in the microcontroller, the number of I/O ports and the timers available in it, the size, packaging, the power consumption, these are the important features. Then next, ease to upgrade, then obviously cost per unit. Next, the availability of the software development tools, the assemblers, the debuggers, the compilers, the emulators, the simulators and the various technical supports, the wide availability and reliable sources of the microcontroller. The 8051 microcontroller has the Harvard architecture. Now the Harvard architecture means it has separate memory for instructions and a separate memory for data storage. It is a single chip microcontroller. It was developed by Intel in 1980 for use in embedded system. This embedded system term is widely used nowadays. Embedded means in which the software, the hardware and the various components are brought together on the single board. Today largely suppressed by the vast range of faster and functionally enhanced 8051 compatible devices manufactured by more than 20 independent manufacturers. Now let us see the basic block diagram of microcontroller. Before discussing the block diagram of microcontroller, I would like to tell you that there is some difference between the microprocessor and microcontroller. In microprocessor, we were not having the memory on board or within the processor. The memory was connected externally and it was accessed through the address bus, data bus and control bus of the processor, whereas in case of microcontroller we have the memory, that is the RAM and ROM and the I/O ports all within the microcontroller. This is the main advantage of microcontroller, that we need not to write the program externally in the memory. Instead we write the program within the microcontroller. It saves the hardware, it saves the cost and it obviously increases the speed of execution. Now let us see the basic block diagram of 8051 microcontroller. In this we have the interrupt control, we have on chip ROM for program code, we have on chip RAM, then we have timers and counters within the 8051 microcontroller, we have serial ports, we have 4 different I/O ports, then we have bus control, we have the oscillator within the controller. Let us see the comparison of few 8051 family members. Actually it is known as 8051 series because there are number of microcontrollers available in the 8051 series with few differences in their features. Let us discuss 8051, 8052 and 8031 with their differences in the characteristics. The 8051 has ROM in it with the size of 4K, whereas 8052 has the ROM capacity of 8K, whereas 8031 has no ROM within it. Now let us have the comparison on the basis of RAM. The 8051 has 128 bytes of RAM in it, 8052 has 256 bytes of RAM in it and 8031 has 128 bytes of RAM in it. Now let us have the comparison on the basis of timer. 8051 has 2 timers in it 8052 has 3 timers and 8031 has 2 timers. Now let us have the comparison on the basis of IO pins. All the three, that is 8051, 8052 and 8031, all have 32 IO pins, that is all have 4 8-bit ports in it. Regarding serial port, all the three have one serial port. Now let us have the comparison on the basis of interrupt sources. 8051 has 6 interrupt sources, 8052 has 8 interrupt sources and 8031 has again 6 interrupt sources in it. Now let us see the pin diagram of 8051. In the pin diagram we can see that there are overall 4 ports in which majorly the overall pin diagram has been divided. These 4 ports are port 0, that is P0, port 1, that is P1, port 2, that is P2 and port 3, that is P3. All have dedicated 8 lines for them, like port 1 has dedicated lines known as P1.0 to P1.7. Similarly, P0 has P0.0 to P0.7. Again for P3 it is P3.0 to P3.7 and for 3 P0, P1, P2 and P3. So these are the 4 ports. Now let us discuss the various pins. As we all know, each controller and processor needs power supply. So we have the VCC line, that is pin number 40. It is used for providing the plus 5 volt supply to the microcontroller. Then we have the ground line, pin number 20, that is known as the reference ground. The pin number 18 and 19 are known as crystal 1 and crystal 2. These pins are responsible for providing the required clock frequency to the microcontroller. Then we have pin number 9 as the RST pin, that is reset pin. It is used to reset the microcontroller. Then we have the pin number 31, that is EA, it is known as external access. Whenever we want to connect the external memory to the controller, or we can say we want to expand the memory, we use this pin. Then we have pin number 29, that is PSEN, it is known as the program store enable. Whenever we want to run our program into the ROM of the microcontroller, we use this pin. Then we have the pin ALE, that is pin number 30. It stands for address latch enable. It is mainly used for demultiplexing of address and data. Then we have the 4 ports in microcontroller, that is P0, P1, P2 and P3. All these ports are 8-bit ports. All the IO pins of these ports are bidirectional. That means each line can be used for receiving the data or it can be used for sending the data. Now let us discuss the crystal connection of 8051. For this we use a quartz crystal which is connected across the pin crystal 1 and crystal 2. This can be clearly seen in this diagram how the crystal oscillator is connected and we obtain the required clock frequency. Now let us see the sum of the registers, or rather we can say the SFR, that is the special function registers of 8051. Each has a predefined initial value, like register PC, that is program counter, its initial or the default value is 0000H. Then we have accumulator, again it has value initial or the default value is 0000. Then register B, it also has the value as 0000. PSW, that is again the program status word, its value is 0000. SP, its default value is 0007. DPTR, it is known as the data pointer register, again its value is 0000, and the all RAM values are also 0 by default. Now let us see the power on reset circuit. This circuit shows when the microcontroller is turned on and we want to reset the circuit. In this, the crystal 1 and crystal 2 pins are connected to 11.0592 megahertz crystal. Our EA bar oblique VPP line is connected to VCC. Then a capacitor and resistor is connected to ground. 30 picofarad capacitors are connected across the crystal oscillator. This forms the power on reset circuit of 8051. Then we can have the power on reset circuit with a debounce. Debounce means when we want to reset externally, then we provide a key which is automatic debounce, means when we release the key again goes back to its normal condition. The circuit is more or less same with a switch, that is push to on switch is connected in it. Now let us discuss the various pins of I/O ports. The 8051 has 4 I/O ports, that is port 0, port 1, port 2 and port 3. The dedicated lines are shown here. The port 0 has pins, that is pin number 32 to 39, and they are P0.0 to P0.7. Similarly, the port 1 has 8 dedicated lines, that is pin number 1 to 8. They are known as port 1.0 to port 1.7. Similarly, for port 2, the dedicated lines are line number 21 to 28. They are known as P2.0 to P2.7. And lastly, the port 3, its dedicated lines are pin number 10 to pin number 17, and they are represented as pin P3.0 to P3.7. Each port has 8 pins. They are named as P0.x to P0.x. These 8 bits form a byte. That means we can say that each port is a byte port. Each port can be used as the input port or output port, or we can say the port can be programmed to receive the data, or the port can be programmed to transmit the data. Now let us discuss the few registers of 8051. The major registers are register A and register B, which are used to perform the various arithmetic logical operations in 8051. Other than these registers, we have 8 registers known as R0, R1, R2, R3, R4 up to R7. These are the registers which constitute the register bank of 8051. There are overall 4 banks, that is bank 0, bank 1, bank 2 and bank 3. Each bank has its own 8 registers marked as R0 to R7. At a time, the microcontroller can work in a one bank, that is, it may be working in the register bank 0, it may be in the bank 1, it may be in bank 2 or in bank 3. Then another registers are DPTR, that is data pointer register. It may be used as 8-bit like DPH, that is data pointer high register, or DPL, that is data pointer lower register. Then there is also a PC, that is program counter, whose function is to point to the location from where next byte is to be fetched. Now let us see the memory map of 8051. In this we have the register bank, that is bank 0, bank 1, bank 2 and bank 3. Then there is a bit addressable area, that is 00 to 3F and 40 to 7F. Then we have the general user RAM. Its area is from 30 to 7FH. After this, there is the area known as SFR area, that is special function register. Its ranges from 80H to FFH. Now let us see the CPU timing of 8051. The most 8051 instructions are executed within the one cycle. The multiplication and divide are the only instructions that can take more than one cycle to complete the operation. Generally, they may take the 4 cycles. Normally, 2 code bytes are fetched from the program memory during every machine cycle. The only exception to this is when move instruction is executed or MOVX instruction is executed. MOVX is a 1 byte 2 cycle instruction that access the external data memory. During MOVX, the 2 fetches in the second cycle are skipped while the external data memory is being addressed and strobed. Now let us discuss the timers of 8051 microcontroller. Now what this term timer means? Timer means to add the delay between the two events which are going to be occurred. As we all know, the delay can be generated by loading a register and down counting till this register becomes 0. So this register will become 0, only then the next event will occur. So we can generate the delay with the help of timers. The 8051 has two 16-bit on-chip timers that can be used for timing duration or counting the external events. The high byte of the timer 1, known as TH1, is at the address 8DH, while the lower byte TL1 is at 8BH. These are the dedicated address assigned to TH1 and TL1. The higher byte of timer 0, that is TH0, is at 8CH, while the lower byte of TL0 is 8AH. Actually this TH1, TL1, TH0, TL0 all are the SFRs, that is special function registers of 8051. The timer mode, that is T mode, is at the address 88H. Now let us see the bit definition of this T mode, timer mode register. The bit 7 is the gate bit. When set, timer only runs while the interrupt high, that is T0. Bit 6, it is counter / timer select bit. When set, timer is an event counter. When cleared, timer is an interval timer, that is T0. Bit 5, it is mode bit for T0. Bit 4 is mod bit for 0, that is T0. Bit 3, it is the gate bit, that is the control bit. When it is set, timer only runs while INT high or the timer 1 T1 is high. Then bit 2, it is the counter timer select bit. When set, timer is an event counter. When cleared, timer is an interval timer for T1. Bit 1, it is mode bit 1 for T1, and bit 0, it is again mode bit 0 for T1. Now let us see the interrupt vector table for 8051. Again we know that interrupt is the asynchronous mode of communication with the controller. Interrupt vector table shows that where the control will be transferred when the particular interrupt occurs in 8051. Whenever there is an interrupt, that is system reset, then flag affected is RST and the vector location, or we can say the control transferred location, is 0000H. When there is a interrupt occurrence, that is external interrupt 0, then IE0 flag is activated and the vector location for external interrupt 0 is 0003H. Similarly, when the interrupt timer 0 occurs, the flag responsible is TF0 and the vector location for this timer 0 is 000BH. When there is the occurrence of the interrupt, that is external interrupt 1, again the flag is IE1 and the vector location for this interrupt is 0013H. Similarly, when the interrupt occurred is timer 1, the flag is TF1 and the vector location is 001BH. When the interrupt is serial port, that is either RI interrupt or TI interrupt, then the vector location is 0023H. So this was all about the interrupts of 8051. We have seen the block diagram of 8051. We have seen that the 8051 has 4 different ports, namely P0, P1, P2 and P3. All these ports are 4-bit ports and each port has its 8 dedicated lines which can be programmed either as the input or as the output. Today in this part of program, we have discussed about the microcontroller 8051 and the family. In this, we have seen the various features of 8051. We have discussed that the 8051 has inbuilt RAM in it, inbuilt ROM in it. It has its own ports. They are port 0, port 1, port 2 and port 3. We have seen how the RAM and ROM are managed within the microcontroller. We have seen the register bank of the 8051 microcontroller. We have discussed that there are 4 different banks in 8051 with each bank having its own 8 registers, namely R0 to R7. We have also seen the comparison of 8051 family. We discussed about the 8051, 8052, 8031 differences. We seen that there are differences in the size of RAM, there are differences in the size of ROM, there is difference in the number of interrupt levels. We have also seen that 8031 is the controller in which there is no ROM available internally. It means whenever we go for this controller to design a particular application, we have to connect the memory externally. I hope you might have enjoyed this session. Thank you.